In this class, we will see about potential energy in an external field. We know by definition the potential energy in an electric field is given by definition, electric potential energy of charge Q placed in the region of electric field is equal to the work done in bringing charge Q from infinity to that point. This we have already derived. So by definition, we have electric potential energy of a charge Q placed in the region of electric field as the work done in bringing unit positive charge from infinity to that point. I can write this as the potential energy U is equal to Q into V, where V is the potential at that point due to electric field. So V is the electric potential at a point where Q is placed. So in this equation, V is the potential where the charge Q is placed. So with this definition, we will derive an equation for the potential energy of a system of two charges in an external field. We'll try to derive potential energy of a system of two charges in an external field. Potential energy of a system of two charges in an external field. So if a system of two charges is placed in an external field, what is the total potential energy? Let us consider we'll consider a origin O, and we'll consider 2 points at a distance r1 and r2 from these two origins. So I'll consider 2 points. Let me say this is r1 and this is r2. These are 2 points we are considering. So consider 2 points say 1 and 2, point 1 and point 2 at a distance r1 and r2 from the origin. So let us say V1 and this is actually in the external field. Let V1 and V2 are the potential at these points. So we have to consider the potential energy of a system of two charges Q1 and Q2 located in R1 and R2. Okay, so let us consider 2 points 1 and 2 at a distance R1 and R2. From the origin O in an external field E. let us say we want to find out the potential energy of the system if we place two charges q1 and q2 at these 2 points. First we will place q1. So we have to calculate now what is the work done in bringing q1 from infinity to that point. So work done in bringing q1 from point infinity to point 1 is given by q1 into v1, because we have assumed consider 2 points 1 and 2 in the external field. So we will say let v1 and v2 are the potentials at point 1 and 2. Let v1 and v2 are the potentials at point 1 and 2. First we will bring q1 from infinity to point 1. So work done in bringing charge q1 from infinity to r1 is work done in bringing charge q1 from infinity to r1 is q1 into v1. q1 into v1. Now let us say we are bringing another charge q2 to 2. Now we have to do the work against the external field E also, and also against the field produced by charge q1. So work done in bringing q2 to r2. In this step we have to consider the work done not only against the external field but also against the field due to q1. Work done in bringing q2 from infinity to r2. So in this case there are two works done. So work is done not only against the external field but also against the field due to q1. Work is done not only against the external field but also against the field due to q1. So total work done is the addition of 2. So work done on q2 against the external field work done on q2 against the external field is q2 into v2. q2 into v2. Another work is done against the field due to q1. Work done on q2 against the field due to q1. On q2 against the field due to q1 as q1 q2 divided by 4 pi epsilon naught and the distance between 1 and 2. So let us say the distance between these two is r12. r12. So this is q1 q2 divided by 4 pi epsilon naught into R12. Therefore, total potential energy of the system is the total work done in assembling the configuration. So, it is the addition of these three equations. Equation 1, 2 and 3. So, adding all these three equations will give us the total work done in assembling the charges in an external. We can write potential energy of the system potential energy of the system is equal to the total work done in assembling the configuration. Configuration means here two charges in an external field. So, this is equal to Q1 into V1 plus Q2 into V2 plus Q1 Q2 divided by 4 pi epsilon naught into R12. The potential energy of the system of two charges in an external field is given by Q1 V1 plus Q2 V2 plus Q1 Q2 divided by 4 pi epsilon naught into R12. Here this is the work done in bringing Q1 from infinity to point R1, and this part is the work done in bringing Q2 when we consider work done in bringing Q2. So, there are two fields. One is due to the external field. So, the work done is Q2 V2, and we have already brought Q1 to this external field. So, there is a field against the work has to be done against the field due to Q1 also, which is given by Q1 Q2 divided by 4 pi epsilon naught into R12. R12 is the distance between point 1 and 2.